You ever try to explain a big, complex idea only to get a completely blank stare back? It's tough, right? Especially when you're trying to get young minds excited about science. Well, it turns out there's a kind of recipe for making it stick, and today we are going to break it all down.
Just think about it for a second. How do you explain camouflage? How do you go beyond just the dictionary definition and make the idea of an animal blending in not just a fact they have to memorize, but a moment of genuine, jaw-dropping wonder? That's the real puzzle we're tackling here.
So to figure this out, we're going to look at a fantastic case study, a children's video all about animal adaptations. And right from the jump, the energy is infectious. It doesn't say, get ready for a lesson. It says, we're going on an adventure. Totally different vibe.
See, the real challenge with teaching science early on isn't about giving kids enough facts. It's about sparking enough curiosity. The best methods don't just dump information. They build a solid foundation for real, lasting understanding. So that's what we're going to do. We are going behind the scenes of this brilliant little video to pull back the curtain on the powerful teaching science that makes it work so darn well. We're going to find out why it clicks. And honestly, the best way to understand this is to think of it like a recipe. This lesson works because it combines 3 core ingredients in just the right way to cook up some genuine curiosity. And here they are, our 3 main ingredients: the question, the story, and the action. Simple, right? Let's break down each one and see how they work together to make learning really last. Okay, first up, the question. This is so important. It's not just about asking something random. It's about framing the entire experience as a hunt for an answer. Notice the video doesn't start by just listing off facts about claws and wings. No, it kicks things off with a central mystery. This one question: how do their body parts help them survive? It immediately flips a switch in your brain. You go from just passively listening to actively looking for clues. You've got a mission now.
And this isn't an accident. This is a very deliberate strategy, a technique you could call a curiosity spark. By posing a really compelling question right at the start, you're not a student anymore. You're an investigator. You're on the case.
So once you've lit that spark of curiosity, you have to add some fuel. And you know what the best fuel is for understanding big, abstract ideas? A good story.
Remember that camouflage problem we had? Well, the video doesn't just define it. It introduces us to Leo the chameleon. And all of a sudden, camouflage isn't some word on a vocabulary test. It's Leo's superpower. It gives the whole idea a character, a purpose, and a little bit of drama.
You know, there's a name for this technique. It's called narrative-based learning. And it works because our brains are literally wired for stories. When you wrap facts inside a story, you give them context, you give them an emotional hook, and that makes them far, far easier to remember. But a great story can do even more. It can be a gateway to an even bigger idea. In this case, the video connects Leo's camouflage to our world, introducing this amazing concept called biomimicry. And that creates a true wow moment. And this illustrates it perfectly. I mean, look at this. We studied how birds fly to invent the airplane. We looked at fish to design submarines. We even got the idea for Velcro from burrs that get stuck to your clothes. This is biomimicry, and it connects the lesson back to our lives in such a cool, unforgettable way.
Okay, so we've got our question and our story, but the final ingredient, this is what really makes it all stick. It's action. It's about getting the learner to stop just watching and start doing.
So the video doesn't just end with a summary slide. No way. It invites the kids to play a game. It's called Animal Pose. It asks them to physically act out the ideas they just learned about. Show me a fish swimming. Show me a bird flying.
This is the principle of active engagement. It's so powerful. When you actually move your body to act out an idea, you are firing up completely different pathways in your brain. The concept moves from something you heard to something you actually did. It's a total game changer.
So what happens when you put all these ingredients together? Well, you get something more than just a really good lesson on animals. What you really get is a blueprint for how to build curiosity itself.
So here it is, the whole recipe in one place. Start with a question to get things going. Tell a story to make it relatable. Involve them with action to make it stick. And then reveal that wow moment to connect it to the bigger world. This is the engine that drives real learning. And here's the most important takeaway of all.
Yeah, our case study was a children's video, but this recipe, this combination of question, story, and action, it's not just for kids. This is a fundamental blueprint for how all of our brains are wired to learn, no matter how old we are.
So it leaves us with this final thought, right? The next time you need to teach someone something complex or even learn something new yourself, think about this recipe. How can you frame it as a mystery? How can you turn the facts into a story? And how can you get yourself to do something with it? Because building curiosity, well, it's not magic, it's a science.